So, ladies and gentlemen, the next session is on DSR, genetics and breeding. And I have the privilege in inviting on stage our distinguished session moderator, Dr. R. Mahender Kumar, Principal Scientist and Head, Crop Production and Agronomy, Indian Institute of Rice Research. Let's put our hands together, ladies and gentlemen, to welcome sir. I also have the proud privilege of inviting all our eminent panelists. May I invite Dr. T.K. Das, Professor and Principal Scientist, Indian Agriculture Research Institute. Warm welcome, sir. I invite Dr. Veeresh R.P. Gowda, Head DSR Breeding, Bio CropScience. A very warm welcome to you, sir. I invite Dr. Mahantesh Gangashetti, APSI EZ and New Initiatives LIE, Corteva AgriScience. Warm welcome. I invite Dr. R.S. Mahala, President Research Field Crops, Seedworks International Limited. Warm welcome to you, sir. And I also invite Mr. Ramanathan, Vairamani, Chief Technology and Innovation, Rallis, India. And ladies and gentlemen, it's my pleasure to welcome you all to this insightful session on DSR, genetics and breeding. We are honored to have with us today a panel of distinguished experts who will share their knowledge and insights.
Sorry to interrupt. Can you ask people in the back to sit and take seats? Yes,
Who will share their knowledge and insights on the latest advancements in DSR. Their dedication to research and development in this field is paving the way for a future abundant and sustainable rice crops. Let us commence this section with the enlightening presentation by Dr. R. Mahender Kumar, who is the Principal Scientist and Head Crop Production and Agronomy, Indian Institute of Rice Research, a renowned figure in the field of rice genetics, and has a distinguished career with significant contributions to agronomy, particularly in the areas of highly productive crop establishment methods, water management, and enhancing nutrient use efficiency. His work includes the development of production technologies for basmati hybrid and the newly released rice varieties, as well as the commercialization of the leaf color chart LCC for nitrogen use efficiency. Dr. Kumar has also been involved in validating and modifying the system of rice intensification to suit large-scale implementation in India. So, ladies and gentlemen, with those words of introduction of our chairperson and the key presenter in the session, may I hand over to Dr. Kumar to begin the proceedings of the session, beginning with his presentation and then moderating the panel discussion. And may I remind you, sir, you have approximately 1 hour to conclude the session. Over to you, sir. And before Dr. Kumar takes the stage, may I request all those at the back to kindly move ahead and occupy your seats. We have a very important session in progress. Over to you, sir.
Thank you, madam. Very good morning to everyone and panelists of this session, DSR, genetics and breeding, where we will be focusing more on availability of seed varieties suitable for DSR and traits for breeding aspects of DSR, then drought tolerance and plant phenotypes. I have a very renowned and very expertise having with our panelists. And most of my presentation points have been covered. I will not take much time. This 5 minutes for my presentation to complete. Myself, Mahender Kumar, working as a crop production section, head at Indian Institute of Rice Research, located at Hyderabad. And we are, coordinating the rice research across the country. That is the main mandate of Indian Institute of Rice Research, which is already 60 years old in India. Next slide, please. And we are the nodal agency for releasing of the varieties. And I'm very happy to convey to you is that we have already started a coordinated network program of DSR evaluation at different ecologies. Okay. And then we will be, I think, soon we will be in a position to release the DSR varieties which are exclusively suitable for the DSR ecology. You all know that I think we are still making it only with 10% of the rice area, and some of the countries which already have 98% of DSR cultivation, and still there is a very big scope for DSR, spreading this DSR technology and suitability of DSR in India, and we are trying to find out that what is the areas which are highly suitable for DSR cultivation. That is our next mandate of IIRR, so that we can also promote DSR in suitable areas. And now it is spreading like anything. The problem is the sustainability of that yield. Many people will come back. I think in Punjab also what I heard is, once it was the area is very much because of their constraints of labor and other things, but whenever their labor is there, suddenly they shifted back to the transplanted condition. And these are, I think, already it has been highlighted, but there are a lot of variability in the DSR based on the availability of water, availability of labor and other things. People go for dry DSR, people go for wet DSR. And these are some of the, I think, variabilities of DSR. There is a broadcasting. Then we need to think about it whenever we are planning for any breeding strategy, which ecosystem we are going to address with this type of ecology. So that's why there are a lot of variability in the DSR productivity also. These are the major constraints. I think already you must have heard with the inaugural session. There are a lot of constraints are there, and as an agronomist, I feel that weeds is going to be a very serious problem in DSR. Whenever we are going for DSR, we should think about how manage, not only with the seeds, we can also see that what are the package of practices we can give it along with the seed. These are the, I think, traits. I think just I'm highlighting it. I think our panelists will be also explaining their opinion about these factors. Like main factor is anaerobic germination. Whenever we go for DSR, when it is totally submerged, then there is a problem of germination. Once the weed population of the crop is reduced, suddenly there is a drastic reduction in the yields. Early seedling vigor is another weed competitive ability. Then you have also heard about herbicide tolerance. Then root traits are very important. The larging resistance. Then micronutrient deficiency is also one of the serious problem. Then drought tolerance and larging resistance. And there are a lot of variability of biotic and abiotic stresses in the DSR when compared to the transplanted conditions. So how to stabilize the yield under DSR, that is also plays a very important role. We have studied for last 3 years in our ECRIP system what are the weed flora, changes in weed flora, and some of the weeds are very difficult to control, which are coming up, which are changing to DSR system, that need to be focused in future. Then there is a lot of differences in pests and diseases also that we need to address while we are planning to shifting to DSR and we are planning for any strategies. And you are also, I think, somebody also already highlight nematodes. I think it is very, very difficult, and I have seen that some of the DSR crop totally destroyed because of this nematode problem in some of the areas where we are working with the farmers. And mechanization, I am very happy to say that we are working with 10,000 farmers of, I think, Andhra, and where only these 3-4 equipments which have been easily connected to the tractors, modified tractors, we could able to demonstrate for more than 10,000 farmers getting a benefit of 10,000 rupees per acre by following this total mechanization of the DSR. But they are using only the varieties which are being suitable for transplanted rice. And I'm very happy to claim it that we have, I think, world's first publicly bred anaerobic hybrid, which is directly go to direct seeded rice in the coming years. And we have some funds available. These are the varieties which are really suitable for the DSR system. We will be going to promote it in a very big way from our institute. And there are most of the sustainable development goals been addressed by DSR, as told by the earlier speakers also. And we need to, I think, focus more on how this DSR yields can be stabilized and improved. and it is going to be a mandate also in coming years. So this is all about, I think, to highlight about this session. I would like to thank organizers for giving me the opportunity. I would like to thank DSR team at IIRR and also for patiently hearing. Thank you, sir. Thank you. Uh, are you able to hear? Panelists, I think I would like to invite first our IRI colleague, Dr. T.K. Das, who is expert in our, I think, weed management in both transplanted rice and direct seeded rice. And he will be sharing his thoughts about how effectively we can manage the DSR weeds. Go ahead.
Respected chair, fellow panelists, distinguished scientists, media, ladies and gentlemen. I'll be just sharing our experiences on DSR. We have been conducting DSR experiment at IRI for last 13 years, but that is in different form. The DSR is zero-till DSR, not till DSR, zero-till DSR with the residue retention. That is under conservation agriculture. So first I will be speaking on that what are the DSR challenges and opportunities and what are the research needs. So first, advantages so many persons have told. And again, just I'm highlighting those things, just repeating this thing, but still some portion, whatever left that I would be speaking on. So, you see, it saves water by 20 to 30%, labor by 40 to 45%, diesel or fuel by 70 to 80%, and also it saves nitrogen by 25% upon long-term adoption of conservation agriculture or zero-till based rice, direct-seeded rice. And then also it improves soil physical, chemical, biological property, and that soils become very, very fertile and it becomes more productive. And it also reduces methane emission by 60 to 70%. And global warming potential is reduced by almost 30 to 40%. And also, it also reduces the Bakani disease. Bakani disease, which is also a problem in transplanted rice, but in direct seed rice, Bakani disease problem is drastically reduced. And also, next crop, wheat sowing is preponderant, or wheat sowing is early sown, wheat is possible after direct seed rice, and all these things. So what are the challenges already told by our previous speaker? But still I will be taking first on some variety. Variety already, DSR specific varieties already Dr. Mahender Kumar has highlighted. So this is really, it is a big boon for DSR. And then breeding for iron and zinc deficiency tolerance. And also moisture tolerance, because initially during the month of June, when high temperature prevails, and moisture stress, it is intermittent occurring. So moisture stress tolerance as well as high temperature tolerance varieties, because that high temperature leads to seedling mortality of DSR, direct seed rice. So that's why that sort of traits should be developed for breeding program. That should be, trend should be highlighted or should be identified for breeding program. Then DSR, in DSR we have also found that DSR chaffy grain, there are more than 10 to 15% chaffy grain in the DSR. That how can we reduce that? That means mostly primarily related to moisture stress. That we have to take into account or take into consideration. Then herbicide tolerance already highlighted, that we have mutation-induced herbicide tolerant varieties. IRI has already developed two varieties, Pusa Basmati 1985 and Pusa Basmati 1979, so they are herbicide tolerance. Now I am telling this is the reality. This is hard reality, everybody highlights so many things. But really, there is always yield penalty in DSR. Last 13 years we are doing, there are at least 2 to 5 quintal yield difference is there in DSR compared to transplanted rice. So how? How we can patch up this? How can we bridge up this gap, yield gap? So what I found that transplanted rice, that we had conservation agriculture base, zero-till direct-seeded rice, we have found that there is yield penalty of 5 to 7% in direct-seeded rice. But if we grow wheat after the direct-seeded rice, there is almost 15 to 20% higher wheat yield under DSR condition. So there is a win-win situation. And if we grow mung bean, then again another boon. So rice, wheat, mung bean system, DSR, then zero-till wheat and the zero-till mung bean, that system is very, very useful system. Why mung bean? Because mung bean, this yield penalty we have seen. And also you see that direct-seeded rice, although there is yield penalty up to 2 to 5 quintal yield penalty per hectare, but when you calculate the economics, always direct-seeded rice is always in a better situation, because there will be 7,000 to 9,000 rupees higher in DSR compared to transplanted rice. Because of that, cost of cultivation in transplanted rice is higher than that of in DSR. So DSR in economically it is viable, although yield, there is some yield penalty or yield gap. Then also that sustainability. What we have found that direct-seeded rice is less sustainable than transplanted rice. But when you see the zero-till wheat, after the DSR, that wheat is much more sustainable than the conventional till wheat. So zero-till based rice wheat system is much more sustainable than the transplanted rice wheat system. The sustainability point of view, yield point of view, there is a win-win situation, but economically again direct-seeded rice wheat system and mung bean system is superior. Then I should come to that this conservation of mung bean. When we take mung bean, so mung bean, it breaks the cycle of nematode. So in the rice root system, rice nematode and wheat nematode, when you grow in between mung bean, it breaks the cycle, so nematode infestation has been lower. And when you grow brown manuring with Sesbania and Crotalaria, again, there is a infestation of little higher nematode in the brown manuring with Sesbania. But when Crotalaria is grown, then direct-seeded rice condition, nematode infestation is drastically reduced. And mung bean, when it is grown, it supplies almost 30 to 40 kg nitrogen through nodule. And also when its residue is retained on the surface, it is giving extra nitrogen to the soil. So that's why it becomes, it makes the soil more fertile. And that's why the system of sustainability of rice root system, that DSR-based rice root system would be promoted in this way. Then I'm coming to the weed shift. Because now continuous use of DSR, we have found there is a shifting of weed flora. So there is much more problematic grassy weed, like your Dinebra retoflexa, Leptocola chinensis, Illucin indica, then Dactyloctonium egyptia, then Dactyloctonium egyptium. These are the very stubborn grassy weed, which could not be taken care of by these traditional bispyrimic sodium. So this weed has to be have to be tackled by different type of other herbicide like cyhalophos-butyl and other herbicide, penoxyram. So that sort of dynamics is occurring under direct-seeded condition. And what is a very major finding from our research is that these weeds act as host of nematode. So when these weeds are present in rice, DSR, so that nematode is transferred from this weed to rice also. So if weeds are controlled, these weeds are controlled by herbicides, so automatically nematode is controlled. So this weed management leads to nematode management virtually. So that is also that if weeds are controlled in direct-seeded rice, nematode also to some extent are controlled. And then residue also, because when we will be using herbicides in this direct-seeded rice, we need to study the residue in rice produce like grain, straw, as well as in soil. And what we have found, that is this is a bright sign, there is no residue of this herbicide found in soil as well as in the grain and straw. There are, I think, 4 or 5 PhD theses have been undertaken on these residue aspects in direct-seeded rice. Then this nematode, that we have found there is 5 plant parasitic nematode, like your Tylencore hincus, then Melodygynea graminicola, Tylenkid, and Petilencas and Rotilencas. These 5 plant parasitic nematode is found in your direct seed rice, and those nematodes are drastically reduced when we control the weeds effectively. And there is a host, and there are 5 nematode hosts we have found in this case. And regarding woody rice problem, woody rice is gradually coming up. But India, particularly in the Punjab, Haryana belt, that problem is not that much. But woody rice will be becoming a problem if we continuously cultivate this direct seed rice. And direct seed rice, this is in Malaysia, Europe, infestation of woody rice has been there 40 to 45%, Italy 70%, Malaysia 74%, USA 60%, and 40% in Senegal, Cuba 80%, and Costa Rica 60%. So these are woody rice infestation in rice. So if sooner or later, if we go on cultivating the direct seed rice, that woody rice infestation will come up. And for that reason also, and also in this part of climate change, there is a prediction and there is a projection that woody rice infestation would be more and its growth would gradually increase in direct seed rice in the face of climate change, because its leaf area will increase, its height will increase, its root system would increase. That sort of report is there. So for that, we have preventive measure, we have cultural measurement, particularly stale seed bed, preventive measure, particularly certified seed, free of this woody rice. We have to nurture, and then we have of course chemical, but although chemical is not that effective. That's pyrosulfuron, petillachlor, and pendimethyline, all these could be used. So for this reason, so we need to have an integrated weed management involving cultural, preventive, and chemical management to control this woody rice, because it is definitely going to be a challenge in direct seed rice in the years to come. So, and also our director has also told about carbon credit, because in direct seed rice, that would be a very brighter area, very big, great opportunities there, carbon farming in direct seed rice. And particularly under conservation agriculture based direct seed rice, taking into all gamut of cultivation practices, agronomic practices in totality, then there would be a huge potential for carbon farming under DSR compared to transplanted rice. With this, I thank you all for patient hearing. Thank you, sir.
Thank you, T.K. Das. I think we will be having one more round. I think if there are any queries from our participants. Now, second, I request Dr. R.P. Veeresh Gowda, who is head DSR breeding program at Bayer. Sir, I would like to know about breeding efforts and approach required to make DSR system more successful. Sir, only 5 minutes, sir.
Sure. Thank you. It's a good question, sir. See, as you indicated in your presentation also, it's important to have a specific breeding efforts. Then only, I think, the kind of aim or aspiration what we are having to meet the DSR needs, I think it is possible with that kind of efforts. When we say specific breeding efforts, mainly we need to see that traditionally or over the many years, either it's public or private, we have put extensive efforts on the TPR breeding only, and no specific genetics or varieties are bred for this particular system. So now I think after hearing a lot of the opening remarks from the first session also, it is very important, and we are all seeing that more or less in a future it is going to be important. So in that context, I think it's very, very important to have a specific breeding efforts at scale, and also at the time of, at the same time, we need to have a adoption of a technology, and also on the genomic side, efforts should go extensively on the direct seeded rice. So what is actually today happening, most of the institutes or most of the organizations, including private, we are keeping DSR as a part of our breeding activities. So maybe we can achieve a little bit, but we don't know that how much the effort is required, whether it is going to be met by the kind of efforts what we are putting as an industry. Because this is an important system. At the same time, the challenges are very big. Unless and until we as a team, all the rice community, if we don't put specific breeding efforts at scale with the technology and the advancements in the genomics, it will be very, very challenging. That's what I feel. So in Bayer, we started putting exclusive efforts, and I feel that maybe as a team, for rice community. If we can start working together to have a specific efforts towards this, maybe it will be helpful to solve some of the problems of our customers, which they are having a pain points today in adopting this technology.
Thank you, sir. Thank you very much. Now I will go to Dr. Mahantesh ji. He is from Corteva Agriculture Sciences. Sir, what are the key challenges for DSR adoption, in your opinion?
Yeah, good morning or good afternoon. See, as you've heard about the inaugural session and also my panelists and they are talking. So, what are the major key concern for the farmer? Is only one of these the crop establishment, and second is the weed management. These are the major two key concerns. So we all this DSR is revolving around these two factors. So how these can be addressed? Can we assure a farmer with a optimum population? What is either 80% or 90% of population? Can we assure him? And if we are assured the crop establishment with the proper population, then next comes the weed. So how we can manage the weeds? So in this first, if you are considering about the crop establishment, there are different functions like agronomical aspects are there. Many panelists inauguration very nicely explained. And then the mechanization comes. So what are the whether we have to use the seed drills? So what type of seed drills we have to use? Now comes to the digital aspects. There are many digital aspects which is including the carbon credits and other things have been mentioned. Now comes to the breeding aspect. What is that breeding can do the offerings? What is that breeding solutions can do for the DSR aspects? So there are many traits which Dr. A.K. Singh has mentioned. Wherever the variabilities exist in the germplasm, definitely breeding team can evaluate that and incorporate into the hybrids or the varieties. As my Veeresh Gowda has mentioned, so till now, most of the breeding efforts in private or public is focused mostly on the puddle transplanted conditions. So yes, you know, all the hybrids are, most of the hybrids perform better than OPV. There are many results and ERI and conducted many experiments. So hybrids, adoption of hybrids in the DSR itself is one of the option by the breeding things. So once you are coming to the hybrids, then what are the traits? So those traits has to be in the parental lines. Apart from that biotic and abiotic stress, we also need to have the producibility and other things which is required for the different segments. So these are the breeding can offer to get the full potential of the DSR technology. That's all from my side. And also the last point is the herbicide technology, which is coming up very well, which is very important, and we need to have the different modes of actions of herbicide tolerance genes is required, and also we need to have a proper stewardship for the herbicide tolerance once it launched to the market segments. That's all my points on the DSR.
Thank you, sir. When you are thinking of hybrids for direct seeded, we need to think of seed rate. I think we need to have that seed rate that plays a vital role, sir.
Definitely. So there it comes to the mechanization. Can we have the 6 to 8 kg of seed drills which can distribute in 1 acre of land? So there it comes to the precision planters. So it is a mechanization has to do some improvements for the this sowings.
Thank you, sir. Now I will go to another expert, Dr. R.S. Mahala ji. He is the President, Field Crops, Seedworks India International Limited. Sir, may I know about that DSR product development challenges and needs, in your opinion?
Thank you, Mr. Chairman. I think I would like to summarize in very brief these 4 points. We have enough information about DSR that has been already recently shared with you through Sadhguru paper. Morning, Dr. A.K. Singh has shared the very relevant points. And a lot of literature is already available about what are the benefits of DSR. But more than the benefit, since we already know, we have enough knowledge about DSR, what are the bottlenecks and where we are stuck, what needs to be done? I think those are the areas and what lessons have been learned so far, where we are stuck and what we need to do. That's the area where we need to focus if we want to make DSR successful in future. There are 4 points here. The one is focus on the challenges rather than more on the benefits. Benefit everybody knows. But enough information is available, but still is not being adopted by the farmers. There's a need to understand the challenges from farmers' perspective. As a research scientist, we know a lot of things, but on the ground level, whether they are implemented, executed, and what is happening, why not they are being executed the way we are doing it in research plots. So we need to think from farmers' perspective and offer the solutions that are affordable, sustainable, and user-friendly. These are the three things that I think we need to focus while we drive DSR. Then drive DSR as an integrated approach, because DSR is not something only about the product. It is a full package. And it is, as we know, that's a full package and it's integrated model. We need to drive it as an integrated model. It requires the right weed management. A lot of information is available on that now. Right weed management solution, right planting equipment, and the right product. Three things together, hand in hand. Three things together as a package, it has to be implemented. Otherwise, very difficult to implement DSR. And more of it's, largely not only the products, but it's more of an agronomy intervention. So there has to be heavy focus on agronomy intervention. The robust DSR testing system and guidelines has to be in place. My colleague, Dr. Mahender, already shared that there are DSR trials formed already in AICRP from last year. I think we need to heavily focus on those trials, come up with the clear clarity on the DSR product traits, target ecology, and the centralized system also to develop and make some DSR suitable germplasm available to all the stakeholders in future. And then policy support, of course, for HT trait approval, then right kind of equipment, subsidies, and other incentives to the farmers, like carbon credits and whatever the water credits and all that has been discussed, also has to be communicated well. So overall, I think these are the key initiatives we have to drive as an integrated approach and a full DSR model. Thank you so much.
Thank you, sir. Even Indian Staff Rice is also thinking about, I think, from this season onwards, we'll be having protocols and special trials for the DSR, germplasm evolution and other things. So now I will go to Dr. Vairamani. He is the Chief Technology and Innovator of Rallis India Limited. Sir, I want to know about rice wheat system benefits of DSR.
Thank you. Hello, everyone. I don't know how many of you will recall a news item that talked about 1.2 million hectares as a key target for Punjab to achieve for DSR in Kharif 23. And against that, what was the target achieved? A mere 77,000 hectares. And why was that? Because the farmers were clearly aware that it is going to be a hot season and water availability is going to be an issue. And we're not confident with the available solutions, they will be able to raise a good crop using DSR. Now, actually, we have seen a list of different varieties which are suited for DSR. And certainly, they carry certain attributes that are necessary for DSR, but not the entire package. Actually, even in the report released by Sadhguru, you actually saw maybe there are 9 categories of traits for which genes and QTLs have been identified. And when I say QTLs, say including the trait that Dr. A.K. Singh mentioned, nematode resistance. They all come as QTLs with less amount of variability contributing QTLs. So multiple QTLs have to be pyramided even for delivering a single trait. So we will have to actually keep our eyes open to see what is going to be the best option. In fact, if you look at literature that came out in 22 and 23, in IRI itself, there is a mutant line 9 that is reported, which is supposed to be extremely good for the graminicola tolerance. So that, I think, is still being studied to understand the genetics and further deployment. But there is another report from China. This came in Nature Communications, which reported a locus called MG1. Unfortunately, it's a major locus. It's a single gene offering something like 96-97% resistance against root knot nematode. So the secret actually lies in identifying smart donors and accelerating this whole mega pyramided variety that we need. And even if we do all of that, it is not going to take less than, let us say, 5-6 years before we can actually confidently say we have a variety ready to be released that will definitely perform well under dry DSR conditions. Now, till then, what do we do? So we need to adapt, drawing inspiration from one of the comments Dr. A.K. Singh made regarding iron deficiency, right? And way back in 2006, I think, Japan actually started experimenting with coating paddy seeds with iron powder and then actually allowing it to rust and then coating gypsum over that and using drones for broadcasting. And they have had actually quite a bit of success. Even there, actually, the penetration is not complete because it is not coming with an entire package that is needed by the farmers. So we need to see what are the agronomic interventions that we can actually pyramid together. See, for example, one of the key requirements in terms of anaerobic germination, deployment of AG. So in varieties that don't have AG, how do we adjust for it? Again, there is a recent publication that talks about nano selenium and nano zinc coating of seeds, which actually leads to longer coleoptile length as well as rapid mesocotyl elongation, which will address. So we will have to have an integrated approach of agronomy as well as genetics to meet these demands. And also, just with science, we will not be able to convince the farmers to shift to a completely, radically different new system. So a farmer who has been cultivating paddy using transplantation over generations is not going to very easily adopt. So the value proposition has to be clear. And there was an initiative started, I think it started in 2009, from CSISA, involving 3 CG institutions that addressed many such issues. Okay, and IRI actually played an active role in India, where they showed that zero-till DSR rice, followed by zero-till wheat, led to a significant increase in wheat yields. Okay, if to keep things simple, if you go with DSR, like mentioned, the duration of rice gets reduced by 7 to 10 days, which actually helps in advancing wheat sowing by at least that duration, which again will help in reducing terminal heat stress in wheat, which is a major contributor for wheat yield reduction over a period of time. So if we are able to demonstrate by developing system-wide practices rather than isolated crop practices, I think we will be able to build a much more convincing case that the farmers will be willing to accept.
Thank you, sir. Thank you very much. I would like to invite any clarifications from the panelists. Please introduce yourself and then you can also the question related to the panelist also.
How difficult or will it be to control that weed? And it is also a point to be remembered that are we getting into a technology which is going to create a bigger problem for us? So can you address this point for me?
Actually, sir, this is survey-based data that I told 70%, that 40 to 50% in Europe. this is infestation, means in the DSR fields where the rice is being cultivated under direct shaded conditions, so the number of fields infested compared to the number of fields where DSR being grown. So based on that, this much percentage area is infested, means fields are infested with the rice. Okay. So that's why that was the percent infestation we given and field-wise. So that is that statistics. And regarding, sir, second question was on?
Means whether the weeds that will get generated or the weeds that will get generated, will it be easy to control those weeds in future?
Yeah. Weed also segregation.
What are the weeds? If there are new weeds are coming, can it be managed?
Yes, sir. Because, sir, that's why I have one of my suggestion or recommendation was that there should be dynamic herbicide recommendations. Particularly DSR, I am telling from the very beginning, to control weed effectively under in direct shaded rice, pre-emergence herbicide should be applied fast. We should not skip anyway the pre-emergence herbicide application like pendimethalin or pyroxasulfuron or petilacor. If we have skipped this pre-emergence application of herbicides, then weed management would be very, very difficult under direct shaded condition. So now then, again, this pre-emergence application of herbicide should be supplemented with post-emergence application of herbicide at 20, 25 days or 30 days in rice as the need arises. If the need arises, based on that. But invariably in direct shaded condition, this sort of weed would be there, and pre-emergence followed by post-emergence application of herbicides are very, very required. Again, I am telling, even after continuous use of these herbicides, these are annual weed killer herbicide. Those are seed propagated weed. So if those annual weeds are killed, and then automatically the perennial weed will take their place. Because like Cyperus rotunda, Cyperus esculentus, these annual weed also gradually come up in course of time. So we have to take care of this weed also. For this reason, I always say that direct seeded rice under zero-till conditions, what our Dr. Vairamani also told, that we have to have our system-based perspective, system in totality, not only direct seed rice in isolation. We have to take direct seed rice followed by zero-till wheat, like the conservation agriculture-based direct seed rice and zero-till wheat with residue system and mung bean in between. That system perspective will do a havoc, and it will be very, very useful, beneficial for the farmer, and that it will be very easy to push the technology among the farmers. Thank you.
Sir, Nilanjan here from BSF. If you can allow me, I will add to you. When it comes to weedy rice, even the conventional herbicide, no matter how robust it, no matter whether it is pre-emergent, post-emergent, it can't control. Because genetically, it is same as rice. So if conventional rice is selective, weedy rice is also going to be selective. So if you want to control the weedy rice, probably you need technology. Dr. A.K. Singh and others also discussed this morning, the HT system. Then you need HT system if weedy rice evolve. Yeah?
Thank you, sir. Thank you very much. Go ahead.
See, just adding to what Nilanjan said just now, there is actually quite a bit of work going on globally using gene editing. So we don't have to be satisfied with whatever are the currently available herbicides which are selective for rice. So using gene editing, we'll be able to expand that range. So predominantly now the herbicides that are usable fall into two categories. It could be either the ACCAs or ALS inhibitors, or actually the tubulin inhibitors like PINDI, but that can be expanded using gene editing approaches to ensure we have a succession in place. Because if you take any single herbicide molecule, weeds are going to develop resistance, and we need to have a succession of technologies available, which is why we need to be thinking about other options that are there, and there is a lot of hope because of the emerging technologies.
Any? Okay. Somebody?
Myself. Sir, I see a lot of inconsistency in data. In Dr. Mahender Kumar's presentation, he said that there is 20% of DSR. That doesn't seem to be true. When the joint director from Punjab said that they could not achieve their targets, and it's like just 76,000 acres, something like Dr. Vairamani said. And in your slide, you're claiming 20%. There is a huge disconnect, seems to me. And other people also mentioned much smaller number than in data. Why do we have such inconsistencies in our data? Because that will affect the policy framing, frankly. So if you could kindly clarify that.
No, sir. It has taken from the total upland and all that, wherever that direct seeding is being practiced. So upland is also considered for this, that percentage calculation. That is also direct seeded. Wherever we go for even bushioning is also direct seeded rice. So many variability of that direct seeding is there. I'm not talking about direct seeding with improved packages. So these things have been, but still we are working on it, how best we can calculate, compute the, what is the DSR area at particular season. So that still we are able to get the exact information on the DSR.
It seems to me that we need to have a clear jargon,
Yes,
so that different people, and these are all of you are eminent people, you know, and give the data which to a lot of people will carry totally different meanings and confuse everybody.
This is the data reported data I have given. It is not, I think it is reported in 2022. That is the area that which I have given it.
Yeah, but the meaning is different.
Yes.
Your meaning of DSR versus the meaning of DSR by Dr. Vairamani or Dr. A.K. Singh or Joint Director is different. That's the problem, is what I'm trying to say. And I hope that there can be a clarity in the definition of what should be the DSR or what is. And that clarity is maintained so that the adoption and the promotion happens correctly.
Anybody?
See, if you just talk about the DSR systems per se, there are at least 13 different systems that have been documented. Okay, so DSR is not completely new to India or Asia. So there are age-old geographies which are traditionally cultivating rice by just hand broadcasting. Okay? And on top of that, actually, there are innovations happening in small patches. I have seen actually personally in Andhra Pradesh during Rabi season, farmers actually wanted to grow hybrid rice, but you know actually the typical seed rate for hybrid rice in transplanted fields is around 6 kg. And you actually cannot broadcast 20 kg or 30 kg of hybrid rice because it will kill the farmer, input cost itself. The farmers actually became really innovative. It was very interesting. They took, actually just saved varietal seed of around 20-25 kg, heat killed, blended with 6 kg of hybrid seed and hand broadcast. And the crop establishment was fantastic. So what statistic was given by Dr. Mahendra Kumar talks about not just the newly DSR adopted areas, it includes wherever traditional practices existed, plus new additions. But certainly, actually, we could clarify that if that clarity is required.
Vairamani sir, are you going to tell about this novel herbicide tolerance traits, which are another 5 minutes?
No, I actually quickly summarize. If one of the other key things we may actually want to evaluate, even though some things are going to be difficult to accomplish. See, for instance, if you take the popular herbicides that have been used on any crop, not just on rice. Glufosinate has been one of the herbicides where resistance development has been really slow, and you will find very, very rare incidence of resistance development among weeds. Now, can we actually take a herbicide molecule like that and adapt it to rice cultivation using any kind of technological approach, making rice resistant to glufosinate? So these are actually the kinds of things that are going to be important for us to challenge ourselves to come out with solutions that will be really, really durable. Because if we have to keep on chasing the weeds because they are developing resistance to FOB chemistries or the cyclohexadione chemistries like cethoxidime, clethodim, and so on, we need to come up with smarter choices which will delay resistance development. also actually think of practices where we can introduce 2 different modes of action for herbicides, because it is very common in BT crops to see 2, 3, even a higher number of modes of actions to pyramid for 2 different purposes. One is for resistance management, the other is to expand the spectrum. A similar approach also can be attempted for herbicide tolerance. It is nothing novel. Actually, in the US, there are at least three GM herbicide traits that have been pyramided and deployed. And GM is not the only option. But we don't have to shy away from that option if it makes sense and if it is really safe after all considerations. I'm not just talking about biological safety, to the larger society as well, because it's a larger debate. It's not a simple decision to make.
Okay, go ahead, sir.
Hello. Yeah, my name's Ketan Mehta from EcoSense. So exactly what you're saying is that there are differences, different technologies available rather than genetic modification. There's, like you said, exactly. So CRISPR is one of those technologies which is way out there and can really help. And it's not, you know, it comes under the umbrella of gene editing. Now, the only thing is, what is the viewpoint of the regulator on that? That is something which then needs to be developed. And that's a lot of countries have worked with that in a positive way. I think that's what also...
No, it was already actually mentioned in the first session. For SDN1 and SDN2 category of gene-edited products, there is minimal to no regulation in India, which is actually a really big thing, because using those 2 categories of editing, we will be able to achieve a lot.
I'm not disputing that. I'm just saying, that, you know, when industry comes up with something, then, you know, then the regulator says, okay, this is what, you know, and that's something that will happen in the future, whatever, 2, 3, 4 years once it comes.
You see, the underlying reason as to why policy decided to almost not regulate SDN1 and SDN2 is it is very easy for somebody who is smart in using the technology to develop a product, completely fly under the radar, don't say it is gene edited. There is no way anybody can find out. Which is why actually the policy also, the framework, decided not to run behind something that you cannot police.
Any queries? Any suggestions? You can also react. Take mic, please, so that everybody can hear. Introduce yourself and then.
Sir, I am Srinivas from Acharya Engineering Agriculture University. Sir, in the state of Andhra Pradesh, we have almost 4.2 lakh hectares under direct seeded rice. So this direct seeded rice that I am talking of is either broadcasting or dry direct seeding with seed drill or wet seeding with the drum seeder, either in Kharif and Rabi seasons across the state of Andhra Pradesh. So can we bring it under carbon farming and transfer the benefits to this 4.2 lakh hectares of the rice farmers? So that would be a very good initiative to spread direct seeding in the remaining areas which have similar ecologies for direct seeding.
Thank you, Srinivas. Anybody want to? Can the direct seeding of that area can be converted into carbon farming so that farmers will get the benefit of their activities?
Sure. Yeah.
So we will have to basically communicate to the policy makers that actually this is available and basically ask them to recognize it. See, carbon credits, green credits, both were mentioned. So basically, we can actually communicate from the session notes through the organizers to policy makers that actually this is happening. This needs to be recognized to encourage more and more farmers to start adopting such practices. But one thing actually, I personally don't believe in a subsidy-driven growth in anything. See, whatever solution we create should actually be fulfilling the requirements of farmer by the farmer procuring things at market price.
That will be the real success of technology. Whatever is there in the Andhra Pradesh, it's most of a wet DSR. It is east and west Godavari. So there if you are coming to the carbon credit, so what is that we are reducing there? Are we reducing the greenhouse gas emissions and other things? So if you go to other Krishna district and Guntur, maybe some dry DSR is there. That can be helpful for inducting into the carbon credits.
3.2 lakh hectares is under 3.2 lakh hectares is under dry DSR. Around 1 lakh hectares is under wet DSR, as you have said, in the Kakinada and Godavari districts, particularly during the Rabi season.
Yeah, they have done a clear survey also, sir, with their manpower.
I will share the details also, sir.
Yeah, just additional point upon whatever the shared so far. So we, in a Bayer, we have a separate initiative or a project we are running on the carbon. So we are actually conducting a trials across India to convert and also give the credits to the farmer also. Maybe we can talk offline and I can share the contacts also so that we can explore that opportunity in the space as well.
Thank you, sir. And third row, madam.
In addition to this, because you see one carbon credit is called that if 1 ton carbon dioxide is removed from the atmosphere, that equals to 1 credit on carbon credit. So in this case, only DSR may not be sufficient and to go for to take it for carbon credit. Along with the DSR, what are the practices being adopted? That also should be taken into consideration, which is leading to carbon sequestration in soil, that sort of things like our director Dr. A.K. Singh told, biofertilizer, green manuring, brown manuring, and other practice which actually encourages or indulges the carbon sequestration in soil. Those things should be taken into consideration. At the same time, how much reduction is there in the emission of greenhouse gases. All these things should be taken into consideration, but this carbon credit still is a very, very complex phenomenon. And it is yet to, we need to go a long way for really calculating the carbon credit from a crop field. Yeah, really long way, long path to go ahead. Thank you.
Thank you, Das.
Just add one point to what Dr. T.K. Das said. See, there has been a survey to look at the amount of carbon dioxide emission reduction in paddy fields following different practices of DSR. It ranges anywhere from 0.3 tons to almost 2+ tons, averaging at around 1.5 tons. So if we do this really smartly, I certainly think benefits can be derived, but we'll have to carefully look at the data.
Madam, go ahead, madam.
Okay. Good afternoon, my name is Anjali and I'm representing 2030 Water Resources Group of the World Bank. We are implementing one project in Uttar Pradesh where our objective is to scale up DSR to 250,000 hectares. Now, when I learn about these 13 different methods that you mentioned, and so many variations are there in terms of right from seed and machinery that is being used, the methods being followed. So if we want to promote DSR and go to new districts and request the farmers to follow something, what will they follow? There is so much of confusion. So we are trying to develop some kind of package of practice or some kind of a common directive, but we are still not able to do that. So we'll be really happy to get some guidance from the eminent panelist about that. And secondly, if there is any kind of a map available, at least for UP, where upland area or areas where dry DSR will work or wet DSR will work, I think that will really help. And we have partnership with Bayer, with Corteva, also with KVK of Rallis. So there are a lot of partners. I'm very happy to be here. And I would like to get some guidance from you all. Thank you.
Thank you. Because actually, you see, madam, we have prepared a lot of literature on direct seed rice regarding the package of practices, starting from seeds, then your climate and soils, what type of soil, climate, then package of agronomic practices, starting from seed rate, sowing method, then weed management, then irrigation management, then nutrient management, then all this, then pest and disease management, all this, there are Packages, maybe you will find the internet, so many that is package of practices there, but it should be authentic one. It is really the booklet or whatever, the pamphlet folder which have come out, that should be authentic, that should be some research based something. Sometimes people write from here and there, they just copy and pasting, that sort of things also there. But we have prepared our pamphlet, booklet on DSR, the different sound management practices for DSR. At least the beginner farmers or those who are really beginners in this field, they can at least take some advantage of those publications on DSR, at least to start something on DSR if he is really novice to the field. Otherwise, because when rice is being grown, most of the people, they know how to grow rice, but for DSR, some specific situation, particularly when I say that conservation agriculture based directed rice, not this till DSR, which is DSR being conventionally practiced. That sort of DSR is tilled, under tilled condition. But our case is zero till condition, under zero till machine sown directed rice. In that condition also some specific recommendations are there that should be followed. And we have publications, I think, that is also available amply. You will see in different fora and different like internet, you will get this information about the directed rice. And you need some authentication of that literature, how it is, then you can contact the experts in the field of DSR. Thank you.
Thank you, Das.
Maybe I can add a few points on that. So when we started in a Bayer DSR efforts, when I say, this was a main question, which DSR we need to focus? Because a lot of experimentation happening, and most of the learnings, whatever is happening today in the DSR, mostly it's coming from farmer innovations. That's where they are not having a right solution. They're going and adapting something, whatever they know, or they observe, or they wanted to solve something, whatever they see. So that's where the lot of innovations are happening, and that's where each one farmer, or maybe Dr. A.K. Singh was also mentioning in the morning, each farmer bringing some different methods. But as a scientific community, it's our responsibility, as Dr. Mahender was also mentioning. It's happy to see that now ACRIP trials are going to be conducted. If we can do it in a systematic and a similar way, then that will be a first step. Same way, maybe if we can see that, okay, what are the pain points of farmer, and then if a general system, if it is followed as across countrywide, then maybe most of the problems what farmers are having, that can be taken care in the common system. At the same time, these different systems can be avoided as well.
Good afternoon. This is, I think, last query. I think we have asked to close the session. Sir,
I'll be short.
Sir. Go ahead.
Good afternoon. My name is Sami Saran. I represent an international NGO called Tanager, headquartered in the US. The India office for us is in Lucknow. I'm the deputy country head. So we have been running a program in Barabanki district of UP for the last 1 decade or more. And this is primarily in collaboration with Marsh Strictly. I'm just giving a short background. The major crop there, and I think Dr. Veeresh, we've met before probably in Hyderabad. The major crop there is mint. But every farmer there, the 30-odd thousand farmers that we sort of engage with, every farmer there, they do rice. And we did some trials on DSR rice with collaboration with Bayer, as well as in collaboration with Corteva. So very correctly, as you said, a minute ago, the farmers actually tend to do the trials as prescribed, and then they innovate, based on their experience out of the trials. And I think what we need is, I think the demand from the large majority of those 30,000 farmers is actually to look at DSR. But I think we need more collaboration, we need more knowledge around DSR, and a general sort of, dissemination of findings of good practice and what works and what doesn't work. And probably it varies, I think, from region to region. So what works in Barabanki may not be exactly the same as what works in Odisha. So, those were just, short comments from my side. Thank you very much.
Thank you, sir. Thank you very much. Any final word from anybody of the panelists? So, I think this panel session, we try to address many of the issues like weed management and breeding traits and how we can sustained DSR cultivation. I would like to thank my panelists for their time and their ideas. Thank you very much, sir, for all of you. And I would like to thank our organization for giving us a chance. Thank you very much, madam.
Thank you very much indeed, sir. May I request our panel to kindly come together for a group photograph. And ladies and gentlemen, let's once again put our hands together to thank our eminent panelists for the wonderful deliberations, some insightful information we had from them.